Hello friends, in this video we are going to discuss about a previous year GATE question on semiconductor. According to the given numerical, it is given that there is a diagram in the question, and in the diagram we can see that a semiconductor bar has been given and a current is flowing of 10 milliampere in the x positive direction, and in the y direction a magnetic field of 0.1 Weber per meter square is applied, and the hall voltage has been calculated in the z direction, and the value of the hall voltage is given by minus 0.1 millivolt, and the amount of current that is flowing is 10 milliampere. So, the dimension of the semiconductor that is given, that D equals to 0.2 millimeter, and this length is given by 2 millimeter. We have to calculate the Hall coefficient and the concentration of the charges and also the type of the semiconductor. So, the Hall voltage is given by minus 0.1 millivolt. So, we can say due to this minus sign is here, we can say the Hall voltage is negative. So, it will give, or it will can be conclude that it is a N-type semiconductor. So, it is a N-type semiconductor because the Hall voltage is negative. Now, we know that the Hall voltage VH mod can be written as B into I into charge density rho into W, and it is given by minus 0.1 into 10 to the power minus 3 volt. Now, from this equation we can find the value of rho, and rho is given by B into I VH into W. So, B, I, VH, W all are given, and W is given by this is the W width. So, if I put all the values, then we can find it as 0.5 into 10 to the power 3 coulomb per meters cube. So, in this way we can calculate the value of the charge density, and we know that the Hall coefficient is given by RH equals to 1 by rho, and rho value we have derived as 0.5 into 10 to the power 3 coulomb per meter cube. So, from this equation we can calculate the value of RH, and the value of RH is equals to 2 into 10 to the power minus 3 meter cube per coulomb. And since the semiconductor is a N-type material, we have found that, so we can say the charge density rho will be electron concentration N into the electronic charge, that is 1.6 into 10 to the power minus 19. So, if I put the value of rho and Q, we can find the value of electron concentration, and that is equals to rho by Q, and rho value is equals to 0.5 into 10 to the power 3, and Q value is 1.6 into 10 to the power minus 19. So, from this we can calculate the value of N, that will be 1.25 into 10 to the power 21 per meter cube. So, this will be the value of the electron concentration of the N-type semiconductor. In this way we can calculate the electron concentration, the type of the semiconductor and the Hall coefficient of the semiconductor. Thank you.